Welcome to Study Loop.
We have an aperture of width 0.0250 millimeters. The wavelength incident is 632.8 nanometers. We want to find out we are also given that I naught is equal to 8.50 watt per meter square. We want to find out the total number of orders of diffraction. We know that sine theta is equal to m lambda by d, and we know that sine theta can have a maximum value of 1, which corresponds to m is equal to d by lambda, which turns out to be 0.025 into 10 power minus 3 divided by 632.8 into 10 power minus 9, which is 39.5, which means there are 39 orders of maximas. Of minimas. Now for part B, we want to find out the last bright fringe. So for that, we want to find out the 39th and 38th minima, and then approximate that this midpoint corresponds to the last bright fringe. We know that sine theta is equal to m lambda by d, which means theta is equal to sine inverse of m lambda by d. So the theta corresponding to 39th dark fringe turns out to be 80.9 degrees, and the theta corresponding to 38 degrees, 38th dark fringe corresponds to 74.1 degrees. So the midpoint will correspond to their average, which is 77.5 degrees. Now, so at this angle, we know that beta is equal to 2 pi by lambda d sine theta. So that is 2 pi by 632.8 into 10 power minus 9 into this d, which is 25 into 10 power minus 6 sine theta, which is sine 77.5, which turns out to be a very large number. Let's call this beta. So we know that I is equal to I naught sine beta by 2 squared by beta by 2 squared, and by simply plugging this into a calculator, we'll see that this gives I is equal to I naught times 1.67 into 10 power minus 6. We know that I naught is equal to 8.5 watt per meter square. So simply by multiplying this with 1.67 into 10 power minus 6, we see that it is equal to 1.4 into 10 power minus 5, 1.42 into 10 power minus 5 watt per meter square. This is the intensity of the last bright fringe approximately.